Hi class, it's November 3rd. Last Thursday we had the Zoom storm and it knocked out AUM's webpage, and we didn't have internet here in my home. We lost that class. I'm trying to manage things so that we can stay on track and be ready for our third cast that's coming up. I guess a week from Thursday, I believe, something like that, November 12th. You can check your amended agenda. So the topic, we're going back a little bit. The topic is using logarithms to solve exponential equations. So I looked at the practice test 3 in figuring out what topics to present, and this is an important one. So let's jump right in and look at some exponential equations. And I'll try to make these from the real world. So world population. It's presently about 7.8 billion. And it's growing at about 1% a year. Okay, a little more than that. It's 1.06, I think, for the last year that I checked the records on this. Actually going down, you go back about 50 years, it was about 2% a year. So now it's about 1% a year. So assuming this continues, so let's solve, the question we want to answer is, when will the population reach 10 billion? According to these assumptions. If the 1% growth rate continues. Okay, so that's our context. Now, when you take your test, most likely you will be given the equation and asked to solve the equation. If you were taking pre-cal trig or a more advanced course, you would have to construct the equation. So here's what we need to solve. 10 equals 7.8 times 1.01. Think of 1.01 as 101% to the power t for t. Okay, so this is year 2020. In year 2021, we would multiply 7.8 by 1.01. That would be equivalent to adding 1%. For 2022, we would multiply by 1.01 twice, and so forth. Okay, now previously, you were given the value of t and asked to find what the population is for that value of t. In other words, given a value of t, find p. That's just a simple calculation with your calculator. You just plug the numbers into your calculator. So previously, we were given t and we found p. Now we're reversing it. we're given a future population and asked to find the number of years to achieve that population. Okay, so the key step is take logarithms of both sides and simplify the right-hand side. Let's see how that works. I'm sorry for our dogs are antsy this morning. So the log of 10 equals the logarithm of 7.8 times 1.01 to the t. And now we have a product, this times this, and we have a power. So go back in your notes or in the textbook, you'll see what the properties are that let us rewrite this. So the log of 10 equals the log of 7.8 plus the log of 1.01 to the t. And another property tells us that this t can come out in front. T log 1.01. Okay, now this equation may look complicated, actually much simpler than this one, because the t is no longer in this awkward position. It's no longer in the exponent. This is actually a linear equation. We just have three numbers here. So this is a number, this is a number, this is a number. So this is quite a simple equation. How do we solve it? Well, we subtract log 7.8 from both sides. And then we divide both sides by log 1.01. Okay, and then now use your calculator and do this Now this is something you have to practice because you have to get the order of operations right. So you might need to have parentheses in order to evaluate the numerator. You want to do the subtraction first and then the division. So you use your calculator. And that answer turns out to be 24.97, roughly. So that's about 25, isn't it? So the final answer is in the year 2045. So 25 years after this year. 2020 plus 25 is 2045. Okay, so let's back away from this and summarize what happens. So I suspect that on test 3 you're going to see equations similar to this one, because the simple applications of this topic lead to this type of equation. So you have a constant on one side. On the other side, you have a coefficient and then a base number, and then the unknown is in the exponent. So you take the logarithm of both sides, and then you have a product and a power. So the logarithm of a product is the sum of the logs, and then another property says you can, when you have log of 1.01 to the t, you can move that t out in front. That's kind of surprising, but it's true. Okay, then you just have a simple linear equation. So this equation may look complicated, but it's really no harder than something like 9 equals 5 plus 2t. You could do that one, couldn't you? So we have a number, another number, and then t times another number. The numbers are more complicated, but they're still just numbers. You could easily solve this equation, couldn't you? Subtract 5 from both sides and divide by 2. So that's all we're doing here. We're subtracting log 7.8 from both sides, and we're dividing both sides by log 1.01. Okay, so let's do another one. And I'm hoping you'll see the same pattern reinforced here. Okay, so this second example, problem 2, you deposit $4,000. Into an account that earns 4% annual interest. With annual compounding. Now, I'm not being, I use the word, the adjective annual twice here, but I have to. I'm not being redundant. We might have had 4% annual interest with monthly compounding or daily compounding. I have to specify this. This word has to occur in 2 places. So how long does it take your money to double? How many years? Does it take your money to double to $8,000? Okay. So I hope you can hold that in your head because I need to erase. The equation that we need is this one. $8,000 is 4,000 times 1.04 to the t. We go through exactly the same steps. Take log of both sides. Now we're going to simplify this so we have a product and a power. Okay, so the other term is log 1.04t, but to the power t. The t comes out in front. And we have our linear equation. We just have three numbers here. So we subtract log 4,000 from both sides.